Okay, this is a limiting reactant problem. So we're going to do a similar problem, asks all the same questions, but a different reaction. So let's say we have magnesium oxide, and I'm going to say that this reaction, so we react 2.40 grams of magnesium with 10.0 grams of oxygen, and 3.60 grams of magnesium oxide are formed. And then we're going to ask all the same questions. So the first thing we have to do is balance the equation. I think in your example, in your homework, the equation is already balanced, but we would have to balance it like that. Okay, then we need to figure out how many moles of each substance we have. So 2.40 grams of magnesium times in 1 mole of magnesium, there are periodic table. Okay, magnesium 24.305. Okay, so I can see right away that's a tenth, so that's 0.1 mole magnesium. And then I have 10 grams of oxygen. And then in 1 mole of oxygen, I have 32 grams of oxygen. And 10 divided by 32 is 0.31 moles of oxygen. And when I look at my equation, I see that I need 2 moles of magnesium for every 1 mole of oxygen. So however much oxygen I use, I would have to use twice as many moles of magnesium. So that means that magnesium is my limiting reactant. If you can't see that, what you can do at this step is divide each of these moles by the coefficient from the balanced equation. So 0.1 divided by 2 is 0.05, and 0.31 divided by 1 is 0.31. So we just divided by the coefficients, and this one that gives you the smaller number is the limiting reactant. Okay, so now it says which is the limiting reactant, and so the limiting reactant is magnesium, and oxygen is in excess. Now we want to figure out how much magnesium oxide would we actually make with our 2.40 grams of magnesium. So 2.40 grams of magnesium, 1 mole of magnesium is 24.30 grams. And then from our balanced equation, we see that 2 moles of magnesium make 2 moles of magnesium oxide. So 2 moles magnesium make 2 moles of magnesium oxide. And then we need to get this back to grams. 1 mole of magnesium oxide, and then the molecular weight of that will be 24.3 from the magnesium plus 16 from the oxygen is 40.3. And so now I'll do 2.4 times, these can cancel, so I don't need to do those, 40.3 over 24.3, and that would be 4.03 grams magnesium oxide Probably have some rounding there. Okay, so that's my theoretical yield. My actual yield was what was given in the problem, 3.60 grams. So percent yield is actual over theoretical times 100%. So it'd be 3.6 over 4.03 times 100%. Is 89% yield. Now the question also asks how much oxygen, how much of the excess reactant was used. So the excess reactant was oxygen, and to figure out how much of it was used, you start with the your limiting reactant, 2.40 grams magnesium. Change that to moles, 24.3 grams magnesium and 1 mole magnesium. Then you use your coefficients from your balanced equation. So I look at my balanced equation. 2 moles of magnesium react with 1 mole of oxygen. So I put 2 moles of magnesium, I put that on the bottom because I need it to cancel with those moles. 1 mole of oxygen on top. And then I need to change this from moles to grams. So I know 1 mole of oxygen has a mass of 32 grams. So then I do 2.4 times 32 over 24.3 times 2. And I find this much easier to do on a calculator that has fractions. And then I just put it in fraction form, and then I don't have to remember all my parentheses. So 2.4 times 32 on top, and 24.3 times 2 on bottom. And that would be 1.5 grams, I think that was 1.5. 1.58 grams of oxygen used. And so how much is left? So how much excess reactant is left? Well, we started with 10 grams of oxygen. So 10 grams of oxygen minus 1.58 grams of oxygen is 8.42 grams of oxygen.